Okay, so we're going to be doing corrections on our proof of parallel and perpendicular lines, our 1B test. So the first one says, two sets of parallel lines intersect as shown. Given that angle 2 is 130 degrees, what is angle 9? So 9 is over here. It corresponds here, and then this also corresponds here. That makes these supplementary. So I have 180 equals 130 plus the measure of angle 9 because of our angle addition postulate. So I'm going to go ahead and I'm going to subtract 130 from both sides. That's going to cancel. 180 minus 30 is, or 130 is 50 equals measure of angle 9. So you would enter in 50 for this answer. Okay. Go ahead and get that put in. Okay, I'm gonna go ahead and clear and move on to the next problem. You can always pause or rewind anytime that you need to. So our next one says a map of the small town identifies shown below the town square as the origin 0. Each block along the street is represented by 1 unit along the X or Y axis. The ice cream shop is at 5.4 and the grocery store is at 3.-2. The grocer wants to install a overhead delivery cable between the grocery store and the ice cream shop to expedite deliveries. What is the length of this cable? Round to the nearest 10th in of a block. So we're gonna go to our picture that we have here. Okay. So first thing we're gonna do, we're gonna kind of count, we're gonna do the Pythagorean theorem for this one. So we're gonna count our rise and our run. So it goes up 1, 2, 3, 4, 5, 6, goes over 2. So we want to find the diagonal. So that's the Pythagorean theorem to find the long hypotenuse. So we're going to have 6 squared plus 2 squared. And then we're going to take the whole square root of that. So I'll pull out my calculator. Let's go ahead and make it like that. There it goes. So when we do this, we're going to go to a calculator screen. Control squared for the square root. 6 squared plus 2 squared. And we get 6.32. So let's go down to our answers. 6.32 would round to 6.3. So number 2 is H. Okay, give you a couple seconds to write that. Okay, so now let me go ahead and let me zoom out. Okay, that was number 2. So let's go up to number 3. Point A is located and placed at -24, and point C is located and placed at 36 on the number line below. Which value would represent the point B halfway between these points? Okay, so we're going to put B about halfway between. So we're going to go ahead and we're going to find the distance between these points. So I'm going to take 36 minus -24 and then divide it by 2. That is how you find the halfway point, our midpoint. So control divide, 36 minus wrong button, -24 over 2. And I actually put 23 instead of 22. My mistake. 36 minus -24. Why'd I put 22? I meant 2. I wrote 2. Okay, 30. 30 is the midpoint. Don't know how I typed in 23 because there's an accident. Okay, so that would be 30. Okay, I'll go ahead and erase. Move on to number 4. Julie is given 2 points, x and y and z. Which steps can be used to find the distance between the points? So to find the distance between the points, what we're going to do is we're going to go ahead is we're going to find our x and our y's. So we're going to find x plus, sorry, we're going to find x minus, or doesn't matter which way you do it because we're going to square it. So we're going to subtract x and w. Make sure you're subtracting the correct claimants. Space. So x minus w or w minus x. When you square it, it does not matter. And then we're going to find the other one, which is y and z. So y minus z, or the other way, they're going to be squared. So we're going to take the square of this, add it to the square of this, and we're going to take the square root. So we're going to use that distance formula. So it says subtract x and w, subtract y and z, square the differences, and then add the squares. Finally, take the square root of the sum. That's what we did. This one says cut off the horizontal distance. So we're not going to count off the distance and add the distances, because whenever we do this, we're going to use the Pythagorean theorem or the distance formula. We have to take that square root. So this one doesn't say anything about the square root. It's just saying adding the distances. This one says counting off. And once again, you're going to add them. So no, this one also says square root, but it's not squaring the right things. It's taking these points and then these points. So they have to be from the separate points in the same position. So it's going to be H. Five, the midpoint of XY is located at the origin, and one point of the segment has the coordinates of 8, -10. What are the coordinates of the other point? So if I were to draw a graph, oh, horrible. A little bit better. So we have 8, -10, and the origin. Okay. Let's say this is 8, and then -10. So if I wanted to go, and this is the midpoint, that means we're gonna have to go this way to make that equal. So the amount that I'm going up is gonna be +10. And the amount that I'm going over is gonna be now -8. So we're going in the opposite direction. So my ordered pair should be -8, +10. See. Because we have to go the same distance that we went here, and we gotta apply the same slope. It can't have a different slope. So, because it's all in the same linear line. So we take this, move it up to find that next part, because this is gonna be the same distance as this one. Okay. Lines A, B, C, D, and OK intersect as shown in the figure below. Next. Okay. AB is parallel to CD. Then it says angle LRB, this one right here, is 3x minus 2. Then RSC is 2x minus 2. Find CSK. So we're finding this one. Okay. So alternate exterior angles. So this is going to be equivalent to whatever this one is. So just like finding LRB. But that means that this form a linear pair. Since this one is congruent to this one, we know that we can add these together to get 180 degrees. So our equation is 180 equals 2x minus 2 plus 3x minus 2. So, and I said minus 2, one of these should be a minus 5. Let's see. Glad I found that. Okay, now we're gonna go ahead and take our calculator. We're just gonna do algebra, algebra, numerical solve. 180 equals 2x minus 5 plus 3x minus 2, comma x, and it says 37.4. That is what x equals. So you're not done. X equals 37.4. So you might have saw that and thought you were done. You're not. Now you got to take this 37.4 and plug it in to this equation here, because that's the one that's congruent here. Okay, those are congruent. This is not congruent. That's going to be supplementary. So we're plugging in here to find out what our angle is. So we have 3, oopsies. We have 3 parentheses, 37.4, close parentheses, minus 2. And that means that angle, even though it does not look like it, is 110.2. So that's going to be H. So you got to use the definition of supplementary. On that one, you got to use alternate exterior angles, a linear pair, help you figure out what you're going to be doing. I'm going to go ahead, I'm going to erase all that. Okay, so that was 6, so now we're on 7. Line LW passes to the point A, 4, 3, and B, 4, -9. Determine the equation of a line that passes to the point 0, 9 and is parallel to the point LW. So this is where you're going to find your slope. So x1, y1, x2, y2. Ooh, that was a really weird 2, but -9 minus 3 over 4 minus 4. Keep in mind the reason this is because it's y2 minus y1 over x2 minus x1. Well, this is undefined. Okay, so this is undefined. The reason this is undefined is because I can't divide by 0, and 4 minus 4 is going to be 0. So undefined when I use Hoy-Bucks is Bucks. Vertical line, undefined, x equals. So we're going to have x equals our x value, and our x value is 0. So we're going to have d. So what you have to do there is you have to kind of figure out where your slope's going to be by setting up your equation. If I have 0 on the bottom, that means my slope is undefined. If for any reason I wasn't sure that it was undefined and for some reason I thought it was 0, plug it into your calculator, control divide, -9 minus 3, 4 minus 4. It literally tells you it's undefined. So undefined, parallel means the same, so we need another undefined one. So it's Bucks, so it's x equals. Okay, let's go to 8. Suppose that point D is the interior of ABC. And then it says measure of ABC is 12 minus 10x, measure of ABD is 3x plus 40, measure of DBC is 2x minus 10. What is ABC? So it wants to know the measure of the full thing knowing these two things. So this is where we use our angle addition postulate. This angle plus this angle equals this angle because part plus part equals whole. So I'm going to add these together and set it equal to this. And I am just going to type all that into my calculator. I don't feel like writing it all out. So I take my calculator, menu, algebra, numerical solve. 3x plus 40 plus 2x minus 10 equals 12x minus 110, comma x. So my x equals 20. Now I got to plug that in here to find out my full measure. So I have 12 times 20 minus 110. And that means my full measure is 130 for the whole angle. So it sounds kind of difficult, but all you're doing is you can use InSolve. You can actually solve it using Don't Call Me After Midnight as well if you'd prefer to do it by hand. But we use our angle addition postulate to add these together to get the whole, find out what x is, and plug it into the triangle or angle that we want. Okay, number 9. The line below passes to the points -2, -4, and 3, 5. Which of these equations best represents a line that is parallel to this graph? So we're going to find our slope. Now, it might not be easy to see your slope on here because it's so, I think this is a point, and I think this is a point. So you can always count rise over run. With something that I can't quite specifically know for sure, I'm going to set up using my slope formula. y2 minus y1 over x2 minus x1. So y2, y1, 5 minus -4, 3 minus -2. When you subtract a negative, you add, so that's going to become 9. That's going to become 5. So we know for it to be parallel, it's got to have the slope 9 over 5. So there's only one that has a slope of 9 over 5. Slope is always next to x, so that's going to be D. D was number 9. Okay, got a couple more. Okay, identify the property, postulate, or theorem that makes the statement true. PQ plus RQ, or QR equals PR. PQ plus QR equals PR. So let's go through our different things here. So we have angle addition postulate. Well, we're not talking about angles. Addition property. Well, we can use addition for that, but that's not specifically the property that we're looking for. Definition of congruent segments. At no point do we use the symbol congruent, so no. Segment addition postulate. Part plus part equals a whole. Segment addition postulate, J. Okay. Okay, so we go back up here to number 11. In the diagram, M and N are parallel. R and S are parallel. Angle 1 is congruent to angle 11. Angle 4 is congruent to angle 10. 2 is congruent to 8. 9 is congruent to 15. And 8 is congruent to 14. Based on the information, what conjectures can be made about the geometric relationship and the patterns between parallel lines and angles? If two lines are parallel and cut by a transversal, the same side interior angles are congruent. That is false. We know that same side interior angles are supplementary. That's one of our definitions. If two lines are parallel and cut by a transversal, their alternate exterior angles are congruent. That is true. But we're reading through all these. Vertical angles are congruent if and only if lines are parallel. Well, these lines aren't parallel. and vertical angles are congruent, so that's not true. Adjacent angles are congruent if and only if they are parallel. Adjacent angles, that means they're next to each other. So here you go. This linear pair are adjacent, but this is not congruent to this. They're completely different. So the one that makes sense is this one. Remember, if you're trying to prove this, if you're trying to make a true information, if you could find a counterexample, it is not it. We found counterexamples for all of those except for B. So B is the correct answer. Okay, last one, I think. Yeah. Given X is parallel to T and K is parallel to W, Karen wants to demonstrate or prove that angle 2 and angle 16 are supplementary. So keep in mind, this is 2, and we want it to be supplementary to this one here. Okay. So now that we know that, we want to figure out what can make that happen. So you're gonna, those marks are about to go away because I gotta scroll down. So given these two are parallel, angle 16 and 1. Angle 16 and 1. Those are called corresponding angles. They're in the same position on the other line. So we're gonna go down, we're gonna look for corresponding angles. And there it is, corresponding angle postulate, number H. Okay, go ahead and submit those test corrections. Let me know if you have any questions or if you need me to work out anything for you again, and you have a great day.